This door so we don't have many latecomers come through and interrupt my flow. You're broken. Right, so today's lecture notes, week 9, we're getting closer towards the end. What are they all about and how do they relate directly, what most students want to know, how do they relate to marks? How does today's notes relate to marks? And secondly, the videos, thanks to my friend here at the front, there's 2 more up there from last week. I do tend to wonder in marking assignment 2 how many students actually look at them, but they are there, you know, so I'm doing you're doing your part. I'm hoping that you don't pass this course, by the way, so you can film it again next year and next year and next year. So that's an advantage. Anyone else want to give their videos to me? You right at the moment? Okay. Yeah, so there's that, and you do need to revise those things, because if you look around the class today, I wish this was all I had to mark. Alright, I've got about double to mark of who's actually attending today. And I know that most of those ones that aren't here are probably going to be fails, but I've still got to mark them, still got to go through them, and I've still got to go, oh, if only they'd have gone back through the video and had a look, the answer was right there. Okay? So, yeah, the reason for me saying things in the lecture is not to be mean, not to be awful, it's to encourage you to come along. Otherwise, I might as well put it all online and say, hey guys, just do it in bed at home or whatever, just go to the beach and watch it on video. So there'll be some stuff today that I'll make very clear that is part of the assignment, okay? And you won't get it in a book, you won't get it in my formal notes, you'll get it here. So just looking at what this is all about today, because I've fielded a few questions. As far as the test goes, which is coming closer and closer and catching up on us, it isn't till after the break from the break in, not this week, but the next week, it's 2 weeks break. It's after that. So it's easy to go, oh, well, whatever, we'll do that the night before. But this lecture, from this lecture, there will be 3 steel questions. I've got a bank of, I think, round about 30, and Moodle will choose you 3 from today's formal notes. Okay? As I go through, I'll say there is a question on that in my question bank. With Moodle, you create a question bank, and then you say, hey, pick 3 of them for every student. Okay? Also, there's going to be your quantities for assignment 3. You'll notice there's a steel section. If we get time today, I might go over it in the lecture, but more likely it'll be in the lab. I have to hold something back to make you come to the labs, and I'll be going over a steel example. And yeah, it's pretty close to your assignment. It's not the same thing, but it is still, I'll be going over something that's got a beam, a channel, an angle, and a plate. And you've got a column, an angle, and a plate. So, you know, the calculations are very, very similar. It's not really rocket science, it's just a case of saying, okay, I understand that. Oh, that's not too bad, I think I can do that. Okay? So I'll go over step by step with that. It's a class example. And what I forgot to say is that is also this bit here in the test. Steel calculations. Oh no, it's here. And we probably won't go over it in the lab, so therefore it'll come from today's, in the notes, so it will come from today's lab, well for some of you tomorrow's lab. So there's real marks here. It's around about 1.5 to 2 marks here. And when it comes to assignment 4, if you don't understand steel, it's going to be pretty hard to draw up the elevations. I'll also give you some tips on drawing up the details today in assignment 4. You don't know yet what details you have to do, so that will either be told to you in the lab or in the lecture. So there is 2 specific little details I want you to do. They're only with 1 mark each. A lot of students go, oh, come out. I'll just flag that, but if you're looking to try and maximise your marks, I'll tell you which ones I want you to do. For the record, a detail is normally a blow up. A lot of students think they can just go copy, look, oh, I've done my detail. The reason why we do details is a bit like getting out a magnifying glass and looking at something a little bit bigger and seeing what the dimensions are, what the welds are, what is the plate, what are the distances, the holes, etc. So today's lab, we've got obviously the notes to go over, and then I'm going to go over something called plate design, which you wouldn't have come across yet in your studies. What plate design is basically putting bolts into a plate and the distances apart that we make them. So there's a few rules. Those rules are in the formal notes. You will be tested on that as well. That'll be one of my questions in the test. When we come to that, I'll show you that. But I'll physically go over a couple of, maybe 1, maybe 2 plates, just so you get a bit of a hang of how one designs plates. I used to do it in the lab, but I think we can cut that out here and do it in the lecture today. And in the lab, we'll do that lab exercise that I was talking about for helping you with your assignment for your quantities. Right. I did say that assignment 2 is taking quite some time to mark. I've finished the degrees. I'm on to the surveys. You guys seem to be last in my line of who I'm marking for. But I will get it done within the 2 weeks. Don't worry about that. Okay. As far as feedback goes, you should. I think you're the middle week in the holidays is handed, by memory, off the top of my head, for assignment 3. Is that correct?
Beginning, I think.
Beginning?
It's in the beginning.
It's in the beginning or the end? Okay, we'll just have a quick look at that. It's no use me telling the wrong thing on camera, or else you're all going to say, oh, but you see it. So what it is week 1, where is this time? No, time tables.
6 October.
Is it 6 October?
Yeah.
Survey. Oh, you got it there on your cell phone at the moment, have you? Yeah. We'll just confirm that, otherwise I say 6th of October and I'm in trouble. You're dead right, here we are, 6th of October, okay. Okay, so I'm in Wellington for a fair bit of that first week. So I would suggest strongly that you make a good bid to try and get as much done this week and next week on your assignment, and ask questions in the labs, etc. Because, and I say Wellington, it's not a holiday. I've got to go down there. We've got a big lecture cluster, blah blah blah, down there for a while. So at the end of that week is the 6th. I should still be able to answer the odd question on email before the Friday, and for those that are heading off to exotic lands like maybe Invercargill or something like that, I don't know, maybe you can try and finish it before the break starts. I should be able, by then you'll know your assignment 2 result. You'll have got some feedback from that. What I'm finding, which is also rather disappointing, is that all the feedback I did, and there was over 1,000 little snippets of feedback in numbers, points and calculations, a lot of students completely ignored it and just did the same thing in assignment 2, which is rather disappointing. Some did, some improved, which was good. But it shouldn't have any bearing on your structural drawings. It's kind of a different kettle of fish. You guys are going to either end up being in structural or in civil. It's really, really rare to do what I did, which is kind of switch careers from one to the other and end up in both offices. Normally you end up making a decision somewhere along the line and end up in one or the other.
Which one is better?
Beg your pardon?
Which one is better?
I've got a similar amount of friends in both, which I will defend one way or the other. They're very similar, but also very different. Personally, I prefer the challenge of working out exactly making something structural work. But by the same token, I guess you get outside a lot more with the civil, and you get a lot more variety, I suppose, outside. Well, structural's different altogether as well, yeah. And you are kind of bound by the guy signing the drawings off to what you can and can't do. Sorry guys, I'm digressing a little bit. Good question. Perhaps we can talk some other time about it. What I tend to say to a lot of students is if you do get a job interview and not just writing a job, if you've actually been asked to go in the door, you've actually put your foot in the door and it can't close, and it is a drawing job of some sort, email me and let me know, and if you're happy for me to act as some sort of reference, that's not normally what we do, but what I can do is I might be able to give you some tips on what they may or may not be asking, okay? We only usually are allowed to give references for the past students because they've worked for us. Yeah, yeah. But it's a sort of a backup thing, come in and have a chat and see what we can do to try and get you. Of course, that's only if you get issued an interview, okay? Not, oh, I'm applying for this job and they might pick me out of 4 million people. Right, so I'm not sure whether we did this or not last week, so I'm just revising the last little bit of the notes from last week because I am testing on these abbreviations. This was the last bit of the concrete, but there's also abbreviations here which are relevant to the steel as well. So just off the top of my head, I'll pick out the important ones that that could well be in the test. Okay. By the way, when lecturers say they are running a revision class, A, go to it, and B, take a lot of notes while they're doing it. Okay. I know for a fact at least 2 or 3 of them pretty much turn up to the examiner's meeting and go, I can't believe students didn't answer these questions when my revision class was exactly the same thing. Okay? So they do it for a purpose. They don't do it just to give you take you off on a radar where you're going to fail. They turn up and they will do some close examples to what is in the exam as such. So Alt is used in reinforcing bars. CRS and CC, they're very similar terms. Centre to centre would be when you're talking about the spacing of a reinforcing bar. Centres would be more when you're, say, talking about the trusses on top of the roof of our assignment. How there may be at 1200 centres, okay, which is, in some of you that are English second language, it sort of means the same, but we tend to go centre to centre when we talk about reinforcing bars, and centres when we're talking spacing? About spacing, both of them are spacings, yeah. DPC is something that you don't have to worry about on your job. Actually, no, you don't. That is normally put on a building between the concrete and the first piece of timber. so the water or the dampness doesn't rise up and rot the timber. DIA, you've probably already seen me using that one for diameter. DWG is the standard drawing, if you're making a reference to another drawing. EF, EW, we talked about that last week. FF, far face as well. Galv is a popular one when it comes to steel. Most steel would be either galvanized, or if it is near salt water, it will be
316. 306 stainless.
probably stainless, exactly. Yeah. Holding down bolts, HD bolt. There we are, there's a simple little abbreviation you're allowed to use on the assignment. You have got holding down bolts. Horizontal, internal, ID, internal diameter. All pipes are called up as internal diameter. This is in civil engineering. The reason for that is it gives the engineer an opportunity to do some pipe design based on how much water can fit inside it. So we don't tend to worry about how thick the pipe is. Obviously plastic pipes are 5-6 mil. It's not usually taken into consideration. So internal diameter is what we tend to talk about when we talk about pipes. MH, you've already come across that with manhole. Minimum, millimetre and metre. That's the only time you're allowed lowercase text on my drawings, when you talk about metres or millimetres. It's kind of odd, otherwise steer clear. Us engineers are fairly boring dukes. We tend to just stick to straight, boring uppercase text. You'll find if you end up working with architects, their arrows turn into squiggly lines, their text turns into everything but wingdings, and it's all to make it look pretty, okay, and try and sell to the client. For us, it's about regimented, good notes that a structural person can build a building that's going to stand up. As I said, it's boring, but it works. PC, precast concrete, also pre-stressed concrete. We talked about that last week. What else? SS, stainless steel. And vert for vertical. Oh, straight as well. I would prefer on your bar schedule, please write straight rather than STR dot, okay? And that's something I didn't go over last week. This week, steel. Couple of drawings at the beginning. That first drawing is a good example of driving past a site one day and seeing a fence around it and just gravel, and then going back about 2 weeks later or a week later and seeing that and going, holy hell, and then going back about 2-3 weeks later and it's all finished and they've moved on to another job. And the reason for that is steel construction is usually very, very quick. It doesn't have lots and lots of noggins and studs, timber studs and noggins. There's not builders going around with nail guns going ka-gung on everything, putting cross bracing on everything to make it stay up. It tends to be a case of a crane on site, trucks pulling up, and a couple of guys swinging off a basket at the top, putting bolts through the steel, locking it in place and moving on to the next one. And they can do it pretty damn quickly. And so if you own a site and you want a big construction like there, a warehouse type thing, definitely you'd think very seriously about steel as your construction. A lot of commercial sites have a built-in factor to their contract if the building's not delivered on time. because obviously time's money. If you're stocking that up with stock and moving it on, time's money. And if they don't deliver your building on time, you're losing money, so they put a contract clause in there. Sometimes it's the opposite, you offer a bonus to have it finished on time, and that's written into the contract as well. So obviously a lot of that can be done in rain, but not heavy winds. The wind is the one thing that can stuff up the construction side of things. There are other ways of joining the steel together, but generally speaking, bolting is the most popular way. We'll talk about that shortly. There's a little bit of a summary of what I've just been talking about. The main supplier, once again, is a company called One Steel. And you were talking about standards before. There's the Aussie New Zealand standards for structural steel, and it also specifies the standards to which, or the tolerances to which they are made. The most popular grade of steel is One Steel 300 plus. That is in the test. Definitely a question on that. Interestingly enough, about 9-10 years ago, I was saying the most popular grade was 250, and a guy in class piped up and said that's not right. And like most students, I just said, no, it is right. And he said, no, not right. And I said, well, why, what are you talking about? He said, I work for One Steel. And I'm coming back, he says, I'll get you some notes on it. I went, okay, thank you. And the first thing that it said on the notes he gave me was the most popular grade is 300 plus. And I thought, oops. So I very quickly revised my notes, put it back on Moodle, and told the students, and it became quickly one of my test questions. The advantage in that 300 plus steel was they managed in 1994 to create a steel which is 20% increase in its load capacity, which means the saving of costs and time when it comes to building.
Did you get half a mark?
Yeah, I probably did give him a half a mark, just like I take half a mark off for silly questions. You love this class, don't you? I know. Okay, standard lengths. This is a chart that he also gave me, which was interesting. I found quite interesting. This was at the time, so it was back about 9 or 10 years ago, and this is the sort of thing that they will give to a structural engineering office, right? And what it's saying is that there's quite a big shortage in parallel flanges, taper. We'll talk about these things shortly, but beams, columns in the 7.5 metre length. And it showed you that the most popular length was 9 metres. They've got quite a bit of that in stock at the moment. So as a structural engineer, if you're told to go away and design a building that's, say, 8 by 8, you'd probably go back to the client and say, well, at the moment, we're going to have to order 9 metre long beams at the same cost. We can do a 9 by 9 building, if you know what I mean. Because all you're doing is chopping the end off and throwing it away, and it's a lot of wastage of steel. So you've got to think in terms of cost when you're designing that. He might come back and say, no, sorry, it's got to be 8 by 8, waste of steel. But generally speaking, this table would be the first thing that you would ask for and look for when you're designing. The other thing is, in terms of trucks, you've got a building that's, I think, 6.8 by 7 point something. That is a very long beam to be bringing to Unitech, turning that corner by gate 4 and coming down the hill and over to your site. certainly wouldn't do it during term time. It's going to create quite a traffic jam up on Carrington Road, and then you've got to negotiate all those trees and everything as well. So yeah, the smaller the member, you know, do you cut it off site, do you not cut it off site, and all that sort of thing. This chart is only for information, don't use it for your assignment, okay? I'm just making you aware that even although it's One Steel's only just down the road, in a lot of cases down in Waiuku, South Auckland, they may not have the beam size you want at the length you want. So initially check that out. Quite a good note actually, isn't it, on your drawings? Okay, I have a bit of a summary here of universal beams, universal columns, rolled steel joists, rolled steel channels, rolled steel angles, etc. But I haven't really explained to you what they are. So I'll jump past this and come back to it. There's a good little photograph of some of them. This one here being probably a beam. This one here is an angle. And this is a channel.
What's the square and the circle?
They're mentioned further down here. We have a circular hollow section, a rectangular hollow section, and a square hollow section. There we are. I haven't actually come across the hollow sections that much, although I have come across a square one a few times. A lot of students say, well, what's the difference between a beam and a column? And the answer is not a lot, except that normally the clue is the beam is very small. The little T section is very small and thin, and it's normally quite tall, whereas a column tends to be about the same width. B and D tend to be very similar in a column, and the middle section is usually quite a bit wider. A rolled steel joist, don't see a lot of those. They obviously have a larger section at the top and the bottom. You've got a beam, and you've also got a column, off the top of my head, on your assignment. I think you've got 4 columns, by memory, and 2 beams on there. Other types of steel members. This is a channel. This is what we call a TFC, and this is what we call a PFC. Anyone tell me why we call it a TFC and a PFC? I'll give you a quick opportunity for half a mark. You cannot get the half mark if you've already got one, by the way. It's only one per assignment. So if anyone's already got one allocated, please answer this before anyone else. The last part stands for football club. No, it doesn't. It stands for flange channel. Flange channel.
Triangular and
Triangular? No.
Tilted.
No.
T face to center.
No. Twisted. Good try. I like the way you're thinking. Doesn't look like that. Next.
transition.
Beg your pardon?
The T for a square and the P for radius.
No.
Is the paper?
P for what? No? No, it doesn't stand for anything naughty.
Plane.
Okay.
Plastic.
Perpendicular.
Well done.
Unless you're right.
Yes, you're actually right. Okay, that's 1/2 mark down the tube.
So you already gave me the hot marks, so
Yeah.
take that. So I'm kind of.
No, yeah, I did, on camera I gave it to you, and then on camera I took it away. I feel bad about that. Oh, you can have a crack at that one. If that's parallel, that is,
Tangential?
what'd you say?
Tangential? Tangent?
Trapezium?
Trapezoid?
Trapezium.
Trapezoid?
Looks like no one's gonna get it. Tapered,
What?
something tapers in.
Yes, sir.
Okay, so tapered flange channel, parallel flange channel. And guess what? It's in the test, and guess what? No one, including you, is gonna forget that. So I've basically given you a mark if you get it in the test. Going back to what I was saying before, and I'll give you one more chance. I'm just in that sort of mood today, I'm not sure why. Oh, I know why. Someone told me that there's a whole new season of Suits out. I haven't been watching it for the last 9 weeks. So that's why I'm in a good mood. Why would I have that? Why would I have a call up that is now called up as 302 TFC 55, but it previously used to be called up as height times width times weight per metre? Why would I say what it previously used to be called up as, when now I'm telling you what the modern way of calling it up on the drawing should be?
Which one is that?
Because some people are old.
Isn't it easier for the calculation?
You're going to lose more than the half mark in a minute.
Understand what it means.
Because it's the standard numbers now. Like the numbers just 200.
That's close, that's not. It's closer. What about one of the ladies in the course? You want to make a noise? You're allowed to if you want to. No? Okay. Your first job in structural, right, is to make a cup of coffee for the boss. The second job is to go to council and get all the old drawings out of a building that you're going to extend. Very common. Rather than a new drawing, you're building, say we were extending this lecture theatre out that way a little bit, you would go and get as much of the steel drawings you can find of this building, right? And you'll find that, particularly that building 112-1100 where our labs are, that was born in the 1960s, and it was built 70s, maybe 60s, 70s, and it was built in such a way that it is a civil defence building. If there's any structural steel in the building, that back then they used to call it up the old way. So you need to understand the old way of calling up a member if you're going to tie into that member to extend a building. So the reason why I put previous there is you can't avoid old drawings when you're doing new buildings and new drawings. If you did a brand new drawing, it'll be quite different. You would start from fresh and you'll be calling up the way that I want you to call it up now. All the beams and columns and everything will be called up exactly like that. Okay? But it's important that I keep that in my notes, just like those old chains and inches per feet and all that, because I want you guys, when you do get one of these old drawings from council, not to sit there and go, oh, Roger never taught me that, I can't do this job. I want you to be able to work out what the scales are and how you call things, how things were called up and how you're going to join onto them. I'm lucky I've lived through an era where I've seen that change, but you guys are in a different era, so, you know, maybe Mrs. Google will be able to tell you, I'm not sure, maybe she won't, but Roger has told you. And also, it's going to help you with your assignment. You can see the modern call up for your members. Check. I think I've been nice to you. I think I've called them up the modern way. But if I haven't, check that they're correct and call them on your schedule that way and on the drawings that way, okay? These little numbers and deflections and all the rest were kind of a little bit more for the days when we had to draw these members up. Most offices you come into will have these already drawn for you. It'll be like a library of AutoCAD drawings, so you can pretty much go and put it into your drawing. And I've done the same for you. I've given you 3 steel members, and you can pick them up, and I'm going to allow you to copy and paste them into your drawing. I don't allow you doing that from anyone else's drawing, but I'm happy for you to use those. And please do, because we're going to, in our 3D demo, I'll be extruding those to certain lengths, and we'll be putting them into 3D. All right. So, at the very least, copy them in the corner and model space. Get ready for using them, but you'll be using them for your assignment 4 anyway, drawing the elevations up, etc. Riveting, just like this lecture, bolting and welding are the common methods of joining steel. So what I've done in the multi-choice is I've added another way in the multi-choice and said which one aren't common methods. I think by memory it was riveting, bolting, welding and gluing. Okay? Obviously gluing being the one that it isn't. Now, with riveting, it's really used these days. And the main reason is that it was, back in the 30s, it was the bee's knees. They were building the Golden Gates Bridge. Many bridges in the early 1900s were around New Zealand. Otago had all the wealth from the gold, so they were putting it into bridges and roads and things. If you go down that way, you'll see all the old bridges with the riveting on it. The issue is that it's the weak point on the bridge. It's the weak point. Rivets are the weak point. So you can make them the strong point by covering them up or painting them continuously. I believe there's a job, there's a guy that paints the Auckland Harbour Bridge. He starts at one end, and after 1 year he goes back to the other end, he gets to the other end and he starts again. It's kind of funny to think like that, but if they don't do that, there's rivets everywhere and bolts everywhere that will rust, but mostly the rivets will rust, and once they're gone, the strength of the bridge is gone. Funny story, the Golden Gates Bridge in San Francisco, the famous one that's painted orange, they were running out of money when they were building it, and the town mayor was the guy that was in charge of distributing the money over there. And the guy that was building it was an engineer, and he didn't think much about colour. It wasn't a big deal. He was building something to stay up. But he was running over budget, and he had to somehow convince the mayor that the orange paint, which was a rust inhibitor, was very pretty and the colour that they should paint the bridge. And he eventually got the mayor to agree to it. And so for him, it was a win-win. He just kept on painting it with the rust inhibitor and didn't have to repaint it with a final couple of coats to make it look a nice colour. So today, they still do the same thing. They don't use any colour, they just use an orange rust inhibitor paint to make sure the rivets are well covered. As far as bolting goes, that's the most common way now that we have stainless steel bolts, etc. And of course, if one bolt does rust for some reason, you can just replace it fairly easily just by banging it out and putting another bolt in. Rivets are a lot harder to replace. They're often in positions you can't get to replace them. Also, bolting is a very quick way of putting members together. Look at that top picture. There would be in excess of about 70 or 80 rivets just in that tiny joint on the corner there. A lot of work. I guess the downside of bolting is you do have to make the bolts a little bit bigger, and sometimes it's hard to line them all up. Steel's not very forgiving. Timber is. You can belt it and get things lined up with timber, but with steel it's not very forgiving. If you get your dimensions wrong, you pretty much got to do it again. The other thing about is welding. The other way of fixing steel members together is welding. What tends to happen with welding is we don't tend to do a lot of welding on site, joining up. Reason? It costs a lot of money to bring the right guys to site with all the gear, setting it all up, health and safety, the whole lot, just to join two steel members together. What they tend to do is they will weld the likes of angles, girts, any other plates or structural members to the steel, bring it to site, and then bolt it to the other piece of steel that it will be bolted to. So they tend to do off-site welding and on-site bolting. That's not a hard and fast rule, but that generally, and it's a question of mine, is the way our steel structural construction takes place. The choice of the connection is usually to do with the size of the members, the loading on the joint, the length of the member, the method that they put it together, and the most economical method of jointing. And that is also involved in a multi-choice question as well. It'd be a good idea to highlight that section of the notes. Bolts. Well, I remember when I first put this picture into my notes and everybody burst out laughing because he was the Olympic champion at the time, and that's exactly what he used to do, is lightning bolt pose. And now you go on to the Tokyo Olympics next year and he won't be there, and people are starting to not hear about him much anymore. So it's going to be interesting to see who actually does turn up there, because they all seem to be getting drug tested these days. But that aside, there are many different types of bolts. There are many different heads on the bolts, and you have to think practically sometimes as an engineer on what the best method of bolting is. For example, are people going to be walking on top of it? I think it was last semester we did a bridge, and there were decking boards on top which were bolted to the steel. The decking boards would be walked on by students who are heading towards a volleyball court. Most likely half of them were in bare feet. So you had to have a recessed bolt. The top of the handrail was bolted on steel. Imagine the students walking along the bridge, holding onto the handrail, boom, ripping their hands to bits. Also, do you need to tighten the bolt up, or do you need to just basically put the bolt into place? Is it going to be threaded into the wood? Is it going to have a washer on it? Is it going to be a strengthened joint? Is it going to be something that's really important as far as strength goes, in which case you want a high strength bolt? Or is it just more like holding something in place with not a lot of weight on it, where you could get away with a commercial bolt? Yep, you could Google this further and come up with all sorts of things. I just wanted you to be aware that there are different types of bolts, and I'm happy for you to choose one of those bolts from my selection there for your assignment. Obviously you have a holding down bolt, so you can't actually get away with not doing that one, but there are other bolts that I've called up that you will need to go into a little bit of detail. There's also some good notes there for your notes section, so have a little read through that, see what you can put into the notes section on your drawings. Bolts are normally called up by the diameter, and we call it, we usually have an M before it. So if we have an M20 bolt, it means a 20 diameter bolt.
Excuse me. How do designer decide to use rivets or bolts?
I guess the answer to that would be back to this part of the notes, where you need to look at the members involved. So are they big steel members? Are they small steel members? Are they just like tin, for example, that you're putting on the side of the building? Maybe you would use rivets for that, might be a lot quicker. If it's going to be large steel members where you've got cranes involved, it's a lot of time holding that there in place where you're putting all the rivets in, maybe just bolts. Tightening up, tightening it up, tightening it up, you wave to the crane driver to move on to the next member a lot quicker. So you need to know the budget, you need to know the time involved that it's going to take, and often the length of the member for handling it. Is it going to use a crane or not a crane? Is it just going to be two blokes holding them in place? All that sort of thing. And then you can work out the most economical way of doing it too. For some buildings it's time, some buildings it's money, some it doesn't matter, just get the job done.
Is that something related which one with the standard rotation force, like moment force or something?
Well, that would have to be worked out, yes. You'd have to do your calculations. I don't know who takes you guys for structures, but it's better a question for a structural engineer taking that to work out what you actually use. I'm going to teach you a little bit in a minute, a few seconds, about plate design, and that kind of determines how many bolt holes you should have and how many bolts, which is similar. And you'll be doing a plate design in your assignment, so it's relative. And what I'm going to teach you in a few minutes is relative to your test, a la steel calculations. Actually, I just remembered the plate design. That is incorrect. That is 4.